Okay, we're gonna try to stream again. I had 2 attempts I did previously. There, okay, I saw it come up on Twitch. Let's see if got audio. Attempts I did previously. Okay, it sounds good to me. Let's see if it came up on YouTube. I don't see the live yet. Let's give it a minute. I upped the bitrate to go to YouTube this time. And I'm transcoding down for Twitch because they only want 6,000 kilobit per second. I don't see it live on YouTube yet. Okay, I see it live on Restream. Restream says it's streaming to both YouTube and Twitch. Is YouTube just slow to pick it up? I still don't see it live on YouTube. I'm gonna give it a minute to make sure it comes up on YouTube. You said I'm live on both? How come I don't see it on the, I don't see my live indicator on this channel. On the YouTube channel. Oh, now I see it's live. It just didn't put the live icon on my profile. Okay. That's weird. Yeah, alright. Looks like it's live. The YouTube quality should be a lot better now, actually. I upgraded it to 10,000 kbps for YouTube since I'm transcoding anyway. So the text should be clear. It should have less visual artifacts and stuff. Well, okay. Let's see. Let's keep up the... We can keep up the YouTube one, that's fine. So, alright. What were we doing? I'm gonna start over here. Alright, good. You got me on both. Live on YouTube. Quality is good. Code is readable. Ah, excellent. Is it better than before? Than the last time you tried to see it? Ah, beautiful. Okay, so I'm glad that worked. And it's still making it through to Twitch, so that means the transcoding is working. Because Twitch would not accept a 10,000 stream. Alright, let's get back into it. So what were we doing? Last time we were working on getting this preview generator to work in the app here. And we were working on getting, you know, this table to work up here. So that we can select the different things. We had to do a little bit of stuff with putting these this rendering on a separate thread. Oh, I got a cat that very much wants my attention. Putting this rendering of the preview on a separate thread so that it doesn't lock up the UI while you do it, and making sure that having multiple threads going doesn't mess anything up. We did some work on setting up disposal of resources, as it turns out for the Microsoft GDI drawing library, it doesn't dispose bitmaps and a lot of stuff on its own, like it should with garbage collection. So you have to go and manually make sure that it gets disposed. So I set that up a lot of places. Let me see the cat. Meow. You want to be on stream, kitty? Look at that, you're on the stream. You're gonna be coding with us. Alright. So, today, I thought I want to add, I'm gonna kind of ignore this profile settings thing I'm doing for now, and I want to start to get a foothold in generating profile images for all the different media platforms like YouTube and X and whatever else has profile images. Hey, we got watch streak. Poolfrog is currently on a 3 stream streak. Nice. Good job. So in order to generate the profile images, Just double check I'm still live everywhere. Yeah, seems like it. Okay. In order to work on the profile images, I got this picture. I showed the actual picture on live on stream the last time, I think. This one. This is the full picture that we just scanned in, drawn by my beautiful wife when we were first getting together. She's a great artist, and she made this nice drawing of me from a photograph that we had. So I've just cropped it down slightly. This is the only processing I've done to it, is I cropped it to be 2500 by 2500. And we're going to make this the basis of my profile photo that shows up on the platforms with a couple of twists. So the idea is we're going to want to load this in and do some transformations on it based on the size of the thing that we're doing. So let's do that. Let's get started. Oh, come on, kitty. All right. So let's start by copying this into the directory, but I really don't want it uploaded on Git, so I'm probably not going to check it into the repository. I'll put it in the git ignore. Make a new folder called inputs to match our outputs. And in the inputs folder, we'll drop this and we'll call it okay. Alright, kitty, I know you're having a good time, but I got streaming to do. Okay, so we grab that in here. Now right now it wants to put it in the Git repository. I don't really want that, so I'm gonna go update our git ignore, which wound up in here. We already added the outputs directory. We're gonna add inputs. And I guess up here we have to add the folder. Add existing item, inputs. What, it doesn't want me to add a folder? How do I tell it this folder is here? Maybe I have to add the item and it'll put it in a folder? No, that didn't work. What, you're worried the PNG comes from an untrusted source? Maybe we have to sync it like this. If I drag it in here, what does that do? Did that copy it? Now it's in both places. I didn't put the file here. It's still only here on the thing. This is really stupid to manage. We remove it here. We got it here. Does that work? Okay, that does bring it up. So beautiful. And this little red icon indicates, just like the outputs, that it's not going into the Git repository. So, all right, where do we start? Let's start by, I think, let's verify in our branding stuff. We already have a profile brand type. Cool, so far so good. Then we're gonna want to make at least one of these profile JSON files. Where did I put those? In profiles? Gonna add a new item, folder/file.cs. That's kind of weird. I hope it puts it in the right place. I don't really like the solution items folder structure thing, but I wanted them to be outside of the actual project. Profiles, let's do xprofile.json. Now, did it put it in the right place over here? No. I put it in the root directory. Let's try that again. If I delete this, it just wants me to remove it. I just have to like put it inside the profiles. Wow, that's so annoying. And then probably have to add it manually over here. Add existing item. X profile. Okay. Now let's start from like our X banner. And this one is going to be X profile, theme X, type is profile. And then what dimensions do we want for this actually? Best YouTube photo, use an 800 by 800 pixel square image, ensuring important elements are centered. Okay. So we're gonna do 800 by 800. For profile images, I might ignore the area of interest. I might not base any calculations on that, but we'll just make it the whole area of the image. Area of interest might not make sense for a profile photo thing. So okay, we got one in here. Now because this is a file in there, it should get loaded on startup. We should see it in this. Oh, no. What's going on? Oh, maybe we hit some kind of error because what went wrong with that? Xprofile.json. Let's go to GUI app form. Okay, refresh preview. Load profiles. What's going on here? Okay, we hit load profiles. Oh, it returns an empty list if it hits an exception. Profiles directory equals yeah. Okay, we got the profile files. It's got to be hitting something in this. Which one is this? Patreon banner is fine. I bet it's got to be hitting something in here. So let's just skip through this until we see Twitch banner, video frame, X banner, X profile. Okay. Profile JSON. Now let's step into this thing. Now, what do you not like in here? Okay, the name is fine. Width and height are fine. Color theme is fine. enum.tryparse. This has got to be the one that's blown up for some reason. No, that was fine. Brand type profile, I got that. Area of interest. Oh, because I said area of interest. The X and Y can't be 0. No, okay, that's messed up. The X and Y can be. It's only an error if the width and height shouldn't be 0, but the X and Y can be 0. Okay, that's silly. I don't need to do that anymore. Okay. Continue. Alright, so now we load it back up here. We're good. And now, right now, there's not really any different code path for the profile, so it got the right dimensions, but it just rendered this other stuff in here. So we're going to take a totally different approach to render a profile image, because it's a very different kind of a picture. So let's go. Okay, we got our X profile there. Let's go into the brand renderer and rearrange this a little bit. So right now I've just got this main render function, and I got to decide which of these elements I want to be in the background and which ones I don't for a profile. So I kind of like the background noise thing that we've been doing. I'm not sure about the binary stuff. That might be noisy for what we want to do. I kind of like the dark halo stuff. The text obviously is not going to be there with all the text effects. The line stuff. Okay. So let's try to start structuring it like this. I was thinking about this originally. Like, do I want one class that does all this, or do I want like subclasses of the renderer? I might actually make this into subclasses. So maybe this turns into an abstract class and it calls some submethods on the full bitmap. Okay, let's try that. This protected, so it can be abstract class brand renderer. This is going to be banner brand renderer. It should satisfy the constructor. Let's do the same thing for okay. It's a public class. I'm gonna make it a subclass. Wait, why do you have to have a using? Branding.app.brand. Oh, because you're not getting. That's not right. Did I not set up the default? Users are in the same directory. They should get the same namespace. Solution, branding, project. It's my default namespace. Branding.app. Oh, assembly name. That's not right. This is the. I messed this up. That's what should be over here. Alright, that's fine. So, okay, we got a brand profile renderer, a profile brand renderer. So now we're going to have to change for unsupported types. I'm just going to add now we got the right namespace. So this is going to be a stub class. Might go away later. So now we made this main brand renderer class, which I think I'm going to rename to in fact, instead of putting this stuff in brand, I'm actually going to rearrange this a little bit. Let's give us a new folder. Renderers. This one. Yeah, base, banner, profile, and null. All of this can go into our renderers folder. Yeah, we want to adjust all the namespaces. And then now that we've got, so this just other typical stuff is in here. And now that we've got that, we can probably remove the word blind from all of these. Base renderer, banner renderer, profile renderer. Okay. So in our form or somewhere, now we're going to run into this issue that we can't create a base brand renderer. So we're going to have to switch on the type to decide which renderer we want. Let's do, I might not fill out the null one. I might just have this like throw an error if you try to use one that doesn't exist. But I want to have a central place that gets the like gets a renderer from the type. And just do like a static one. Base brand renderer dot create. I'm not going to call it base, I'm just going to call it renderer. Because that'll make our static method a little bit nicer. Oh. Alright, so inside here, we're going to look at switch on the type. And we're going to say brand type banner. I'm going to create that. Profile. Then return that. Yeah, I'm not going to make like a null implementation of it. This is going to return optional. What's wrong with profile renderer? It's not a constructor that takes one argument. Oh, so I never finished coding it. Okay, so now over here where we render, instead of doing this, we're going to say come on, this one. Not create the profile for the profile. And then we're going to say if render equals null. And what do? How do we break out here? We just return. We've already made the thing. If I can't create one, do we leave the last one, or do we just maybe we just leave it blank? So if the renderer is null, then maybe we just immediately we don't set a preview picture box image, but we do hide the label, so it's just going to be black, and then we return out early. So if it couldn't create a renderer for that type for any reason, and then when this one gets the preview picture box image at the beginning to dispose it, if the one is null that's already there, then it's not going to do it. It's not going to try to dispose a null reference. Alright. So now this should be back to doing the same thing it was. Did I mess something up? Base brand renderer could not be found. Oh, and the render manager thing over here. This is not even in the right namespace. Branding. Oh, what have I done over here? None of this is in the right namespace. Manager, branding. Branding. Okay. Here we're gonna do the same thing. We're just gonna say render class create profile. Well, if we don't have a renderer for it, we're just gonna skip. We're not gonna render it and put out an image. Okay, I probably have to fix a couple of these namespace references here. Use the branding. Probably have to build it for it to find all of them. Oh, I only needed that one. Okay. So, alright, this is working. That came back up. Nope. Cross thread. Oh. It has to be in the UI thread. Okay. Whatever, bro. No problem. So we have to call this hide thing from the UI thread, which means we have to use this little sync UI utility. That's fine. Okay, so this is still working. And now we gotta separate these things out into subclasses. Video frame. Oh, I don't have a video frame renderer, so there's an example of what happens when we don't have that set up. Maybe I'll go ahead and add that as long as I'm gonna do these. So in our renderers, at some point I'll also have like a thumbnail renderer. Okay, no problem. So now, in our main renderer, let's think how we want to break this down. I kind of want this render function to still be the master thing that does everything, but I want to get some appropriate like abstract methods that each of these things have to override. And probably, instead of making them abstract methods, I'm going to make them virtual methods that start with an empty implementation. So that if you don't override them in the subclass, it just draws nothing for that step. And then we'll kind of give ourselves a little vocabulary of methods that like different types could actually render from each one. I could pick and choose from each one. So let's try to structure it like that. So before our create, let's get, what are our different steps here? So this one should create a thing for this whole size and clear it to black. That should always happen. Then we can have a function to make the background noise. I'll have that take I wonder, do I actually just want to make the output bitmap like a class member, like a protected class member, so that they can all just operate on it? That might be cleaner than having to pass it, you know, everywhere. I mean, the only place that gets kind of messed up is if for some reason one of these renderers, right now I'm creating a new renderer each time I render a thing, so it's thread safe. Like, you're never going to have one rendering both. I'm just thinking if it's going to get really annoying to pass that around everywhere. No, I'm going to pass it around right now. We'll have a fill BG noise function. And that one's going to do this stuff. Go ahead and pop it down here. Before I do that, actually, each of these is going to have to do the disposer thing. Before I go further with this, I'm going to rename full BMP to be out BMP, so it's really clear which one it is. Okay, so we're going to call that. Then we're going to call the fill binary. I'm going to, instead of fill, I'm going to call this render BG noise. It doesn't have to be public, it's only going to be called inside. It only needs to be seen by this class and the subclass, so I'll make them protected. So render binary layer. We'll call these layers. And now we're going to have to do this thing again. And we're going to take all of this stuff. Right? Okay, no problem. Now the disposer is still called DSP everywhere, so copying that code just works. Let's get our dark halo stuff into a layer. Okay, and then this stuff. Oh, here, look, I was already switching. What type of parameters it is. I wonder if I want, because I know for a fact that I want the settings of this to be different for a profile filter. I might have a different abstract method that creates the dark halo filter in general. I might do that for a few of the things, so that you could override just creating the thing, even if you want it to be applied the same way. But for now, let's take all this in there. Down here. Okay, I'll do that stuff in here. Now what's our next layer? The text stuff and all the text effects. All of this together. But the problem is that those get referred to down here. So how do I want to structure that? If I need references to these text bitmaps that are going to come out, and I need references to these line bitmaps that are going to come out. Oh, and here I was even applying the Dark Halo one in the middle. Probably. Well, I guess I would just compute them separately. So I would have a function that draws the text, and it's going to compute this stuff and draw it, and then I would have a function that computes the it's going to have like out parameters. It's a little bit messy. Let's leave that one alone and just do the easy part first. Well, actually, that is the rest of the easy part. The gradient generator could be separated. I'll grab this stuff. Alright, let's think about how to pick this part apart a little bit. So the reason I'm doing the Dark Halo in here is because I want it to draw the text, and then I want it to draw, or sorry, not the other way around. I want it to draw the lines, and then I want it to draw the halo on top of the lines. You know, we can't even really see that when it happens. I don't really care if that's there. I think this one is just going to go back to when we do the Dark Halo layer. So we create the filter, and then we apply it to the out bitmap. I don't think that was making a big difference. So now we almost have drawing the text and drawing the lines separated. Actually, you know what? Maybe I'm going to keep all this together in a function. It's called like a draw logo or render BC logo layer. And let's take this whole chunk in there, because this whole chunk is not going to get done, the lines and the text, like for a profile photo together. All of this section, including the layout section, which actually ends up drawing those two things. All that should be able to go in here. And yeah, it doesn't refer to anything from outside. Okay, cool. So that's cool. Now I don't really need these comments. Alright, so now our render method calls these chunks, and each chunk is overridable. And from up here, we're probably going to decide which chunks we actually want. So oh, well, okay, let's do it like this. Maybe we should have abstract properties or something. Yeah, let's do it like that. So each subclass is going to tell. supposed to be. So let's get one of those for each. 1, 2, 3, 4, 5. Needs binary layer. Needs dark halo layer. Needs C logo layer. Needs render gloss. Gloss gradient layer. Okay, so these are abstract, so these have to be overridden by the child implementations. So let's go to our, this null renderer, we decided we don't need it, so just get rid of that. Let's do the banner one first. So now it should be complaining that it doesn't implement the abstract things. Okay, these are going to be override, I think. And can I use this syntax? Does not implement inherit. Oh, okay. I don't give a shit about that. So, is it enough to just give these gets? I guess so. It means it must be some kind of constant, or maybe that's specially allowed for abstract ones that don't have an implementation. I guess that's kind of how it works in interfaces. So maybe that's fine. Okay. True needs dark halo layer. True needs BC logo layer. True needs gloss gradient layer. True. Okay. And in the main class, in the main renderer, I'm gonna say let me do that. Needs the binary layer, let me do that. Then we do that. Then we do that. Then we do that. So now each of these subclasses can turn on or off certain parts of it. We put these ones here. Let's also put them in the profile renderer subclass. When it occurs to me, my view is covering up the thing over there. That's fine. Let's just change it to the coding view. Still lined up right? Like that. That's fine, I guess. So here, these are going to be different. So for the profile, let's keep the noise for now. Let's turn the binary off. Let's keep the dark halo. Let's leave the logo layer off. Let's leave the gloss gradient layer off. So we're just taking the BG noise part and the dark halo part. How's that going to work as it is? Don't want to mess anything up. Mess something up. Oh, because I made a frame renderer, so I need to give that same stuff over here. So for a frame renderer, probably needs BC noise layer. Okay, true, needs binary true, dark halo true. Actually, I don't know if I want the, well, you know what? I'm not really thinking about what I want for the frame layer, so I'm just going to turn the BC logo layer to false and the gradient to false for now. We can revisit those decisions later. Okay, that lets it build. So here we've still got, this still looks the same as it was, which is cool. The Twitch banner should still look the same as it was. Something, did the text always look like this? Am I trolling myself? Is it just because it's large? Something about the text feels a little bit different. I'm not 100% sure what it is. Video frame always takes forever to render. Oh, because I haven't set up the frame renderer, so that's why we don't see the generator. X banner looks okay. X profile now. Ah, look at this. So now we've got this nice clean place to pop a profile photo. And then the YouTube banner one should look the same as before. Wow, it takes some time. Alright, cool. That looks normal. Alright, that's doing what we expect. I'm going to take just a quick break, and then I'll be back, and we'll start pulling in this beautiful photo and start manipulating it. Okay, and we're back. Let me go ahead and check this change into Git really quick. Pop that in there, pop it up. I probably should have done this before the commit, but I will go into that base renderer class where we create them from the type. And remember to add the frame one. So now if I pick video frame, I should get one that's a little bit different. Yeah, here. So we just have like kind of the background that has the binary stuff on it. And for the profile, we have kind of like a smaller square that we can put something on. Okay. Now let's add a new layer here that would go, let's say, after the BC logo layer. What do we want to call it? The photo. Profile image. It's the generic term. I guess we're gonna call it that. So it needs profile pick layer. No, the pro pick layer. It rolls off the tongue a lot easier. We're gonna structure this the same way. I think I put it before. Where did I put this in? After BC logo. Okay. How come I have BC logo? This, I try to keep this stuff in the same order, even though it doesn't really matter. It just helps keep it straight later. Here we'll have now, do I want to write the code for that in here, or do I just want to leave it off, basically? I want to keep the code in here that's going to be general between them, and then I don't want to pollute this with the code that's only going to be used for a specific one. So are there like other versions of this thing where I might want to put the pro pick? I think that's only going to be for profiles. So I think I'm going to confine it to the profile renderer class. Excuse me. These are the kind of decisions that you have to reason about how you want to organize stuff. Like, do you want to fill up this class with it? Do you want to put it in a separate class? And why? Like, on what basis? So that was just me reasoning out loud the basis for the decision that if pick. That was just me reasoning about if this profile pick stuff was going to get used in multiple types, like multiple brand types, like a banner and frame and whatever, then it would make more sense to put it in here. And pretty much everything that's in here right now is stuff that's going to get used by multiple types, including this BC logo one, theoretically, because there's an argument that maybe this only goes in the banner one because it's supposed to be a banner image. But at least right now, I'm imagining other types where I might want to have the logo on it, like thumbnails and stuff like that. So I'm gonna leave it there for now. Oh, you know what? Actually, now that I talk about thumbnails, do I want the profile pic to go in thumbnails, to get rendered into thumbnails? Maybe. Maybe I do. Maybe I'll just keep it here. I'll just keep it here for now. That's fine. So, alright, we made it an abstract thing. Now in here we're going to check so we're going to give it the opportunity to render. We're going to have to go to all things, all these things. So the banner doesn't need it. The frame renderer doesn't need it. And the profile renderer does need it. Okay, so now whatever we do inside this class, we have potentially a lot of stuff that's going to happen in there. Same normal pattern here. Alright, then where do we even want to start with this? First of all, we need to load up that profile picture that we put in there. Which I think, can we do like bitmap.from file? Hey, that's convenient. Do I need to have an inputs directory somewhere? Like that. String type. Okay. What am I hearing? Is that an airplane? I can hear it on the headphones. Combine. This is going to include inputs directory path and I believe that's what it's called. Is that what we call it in here? Barton drawing.png. Okay. Then let's call this the raw path. Okay, now for just a very simple example, g dot image raw. I think we can give it a rectangle, right? I like the area of interest rectangle, which for the profile thing is going to be the full one. So this should just stretch down the raw image that it loaded in to be the size of the output and draw it onto the output. Hey, there it is. Beautiful. If we stretch this up, it should get bigger. Alright, excellent. That's an excellent starting point. Now from here, we got to think about how we want to structure it. I think first I want some kind of filter or generator I think I want a generator that cleans this up. So I'm going to pass it a full-size bitmap and the size that I want it to be. And what I want it to do is basically clean it up to grayscale and then clean out anything below a certain size. Or no, actually, we'll, instead of that rule, we're just going to have it take the intensity of the pixel and make the alpha the opposite of the intensity of the pixel. So basically, any of these, the darker that they are here, is how much alpha they're going to get in the grayscale image. Now, if I do that, do I even need to... how am I going to do the colors for this one? Do I want it to put this out as like along a very specific color, like a base color? Or do I want to have a gradient, like the darkest parts get one color and the intermediate parts get like a second color? Maybe that would be a cool way to do it. So I could give it like the highlight color and the like a different color, like the texture color or whatever. And then the pixels that are like intermediate dark are going to be one color, but as they trend towards like maximum dark, they're going to be the other color. And then I'll take the whole thing down by the alpha. That might be a cool way to do it. But in any case, let's start structuring it into the generator class. We're going to call that like a line art generator. Oh, what happened here? I just started coding a class without, oh, I started coding this method outside of the class. That's what happened. Okay. Alright. No, I needed to have a constructor. I think I'm just going to hand it the parameters with initialization. So we're going to give it a source. No, this doesn't need to be a rectangle, it just needs to be a... So we want it to have an out width and an out height. Then we want it to have like maybe if it's starts from black or white. I'm really only going to do it for this image and it's going to be white, so I might just not even parameterize that for now. I could always come back and parameterize it later if I was going to load in like a black background image and try to do the same thing. So I'm just going to assume that it's white for now. Then we probably need an input min and input max intensity. So here I'm thinking, like, if you think of the darkness of a pixel, like all the way from 000 to 255, 255, 255, we probably want it to basically chop off anything like up to this brightness and down to this brightness, and then normalize what's left to take to take up the full range again. And that normalizing is going to be important because if what's most likely is that there's maybe a little bit of noise, like a little bit of noise down here at the bottom of the range. Well, actually, I have to think about this right. I wonder if I should invert the color first. There's going to be a little bit of because most of it's going to be white. So let's imagine I inverted the color so it becomes black with lighter pixels in the middle. That's easier for me to think about black as the background. We're going to probably have a little bit of noise down here near the bottom, which is like where the scan didn't completely filter stuff out. And we want that to just get deleted so that if we do effects or brighten stuff later, it doesn't have like a lot of kind of gritty noise in the background. So we want to be able to set that floor. And then up here at the top, it's likely that there's no pixels that are like the maximum intensity. We'll probably only get to like half intensity or like 2/3 intensity or something like that. But for our output image, we want those pixels that were the highest to become the maximum intensity. And it's supported by the image. So that's the basis on which we're going to normalize it. So let's do a few things here first. We've got our disposer pattern. So get us an out bitmap going based on the output size that we want. And the first thing that we're going to do is just draw this one. We want to make a note. We're not going to dispose it, but this graphics thing we aren't going to dispose. Draw image. Oh, and here we need the what do we want for the thing that we're going to draw it into? I guess here for this one, like if we have a thing, we're position it afterwards. So we're just going to assume that we're drawing it 0 to out width and 0 to out height. So draw image here is going to take the source BMP that we passed it, rectangle from 0, 0, out height. Okay. So if we do that, now let's come back over here to the renderer, and instead of doing this here, save that in case I need it later. In fact, I am going to need it. Instead of doing the call here, we're going to do no, this generators we don't add. Okay. Line art generator. It's going to source BMP is going to be raw. Oh, it gives me back an image. Bitmap.from file gives me back an image. A bitmap object. It's like a generic, but it's gonna be a bitmap, right? You know, if the first thing I do is draw it, then I don't really care. I'm just gonna have it match this file. Oh, bitmap.from file is probably, maybe it's giving me this because it wants me to call image.from file, and bitmap.from file inherits that. The image this method creates. image.from. Yeah, see, look, even when I hover over it, it says image.from file. So it's clearer to use image.from file here. And then, can I like make a new bitmap from it? I think that doesn't really matter. I'm just going to take it in as an image over here in the line art generator. In fact, it was occurring to me as I was doing this project, I'm using bitmap all over the place as the most generic type of image to pass around. Probably I should be using the image class more places so that if I needed to, I could put in some other kind of image. Doesn't really matter for this project, but could do it if we wanted to be clean and proper. So, alright, now I can accept that. Out width is going to be... Alright, so creating that, we're going to do... line art equals. This one we do want to make it disposable because we're just going to draw it. Okay, then down here is where we're going to use this call. We're going to get a graphics context for the out BMP, and we're going to do and here we should just need to pass it. Does it have one that'll just take that, or wants at least a point? I'll take an X and Y. I'm gonna draw it at 0, 0. Actually, you know what? Here's where we'll do. So we're still honoring our area of interest stuff because we're going to draw it back onto the image at the area of interest. It just so happens for the profile one that that's 0, 0 anyway. No, that's the only place we're using it right now. Okay, and then we don't have to return it because we got past the outg in. Okay. So this should get us back to where we just were. It should be doing effectively the same thing. And then it just loads in the image and paints it on the screen. Okay, cool, cool, cool. So now, first, let's figure out how to invert it, because that's the way that my brain works. And we'll, we'll actually bake that in. So this thing is going to assume, not that one. This thing is going to assume that the background is either black or white, because I don't want to generalize it all the way to think about like all the different colors of the background of the picture that you scan in could be. So I'm just going to assume it's either black or white. We're going to pass it a Boolean white BG1. Just have it default to true so we don't mess it up. And the first thing we're going to do here is basically if white BG, then we want to get our we want to invert our source bitmap first before we draw it. Now what's the easiest way? Because I could go and do it like pixel by pixel. But surely they have a method for it. You can iterate through pixels, use pointer manipulation with lock bits. And the color conversion itself is cheap, but there isn't a method to do it. You just have to iterate the pixels and reverse them. Wow, that's so stupid. Alright, fine. So actually let's draw it to the out BMP first, because basically as soon as we draw it down from 2500 by 2500 to, in this case, 800 by 800, all of the other operations are going to become a lot faster because we're going to have a lot less pixels to work with. So we could invert it before we scale it down, but what's the point? Like, we're just going to be working on way more pixels than we have to. Alright, let's just do it. Let's just write a loop to invert it. Let's do Y first. It already knows what I want to write. And for each one, we're going to do C equals that's Y. I'm not going to do. Now, do we want to try to do the alpha manipulation at this stage? I think that's going to be a separate pass because we only want to do this one if it's a white background image. And then after that, we'll go and manipulate the alpha and all the other stuff probably as one pass. Once we know that we've got one where the BG is black. Okay, so then we're going to do set pixel x, y. It's always this at this phase we're always going to have 255 alpha. So I guess this also doesn't really matter. Always 255 alpha, and then we're going to go from so we're going to invert the red, invert the green, invert the blue, and yeah, okay, so then we just need to make sure. I know I already defaulted it to true here, but just to be explicit. Now let's keep it in the same order. So we'll tell it this image has a white background. So is this going to give us our inversion? It's going to give me a compile error. Okay. Need an extra one of those, whatever. Okay, so there's our nice invert. And it does look like the stuff must have been already black before. Because, oh, that actually looks beautiful in the inverted already. So I think this is going to work really well when we mess with the colors a bit more. Alright, so now is the next pass. Let's make it take, I'll do these as ints from 0 to 255 since they're colors. I want it to have the source min intensity, source max intensity. And then do I always want it to max out the intensity? Probably at this phase I just want it to always max out the intensity, and then I can like darken it later. That's probably fine. Let's start like that. So these are the two things I'm mainly interested to configure. And then we will, for now, I'm going to give it, open the renderer. It seems like it's pretty clean, so I'm going to give this a pretty low value, like 16. And for right now, I'm going to let it be full intensity for the max. No, we'll give it a little bit below that so we can see how much dynamic range we get. And later, once we see what it looks like, we might fiddle this number to see how if we're making the lines too bold or, you know, chopping off too much of the detail. Okay, in the banner renderer, no, why are we doing this? Oh, it's just right above, right here, okay. In the line art generator, that's what I want. So now we're going to do our main pass over the image. We want to get the same X and Y loop. I might end up making this thing a padding too if I decide I want to do some kind of blur thing, but I might do the blur stuff outside. I might try to keep this line art generator limited to just the color manipulation we want to do. Okay, so I have those two. I also want this, what did I say? I wanted to take like a 3, let's make it take 3 colors. So we want it to have the color, like a bottom color, like a mid color, and a top color. And maybe I want to give it an intensity value for where it switches, like where the mid color is. And I think I'm actually going to pre-render a lookup table for what color to make each pixel. Now that's another thing we need to do. In order to, there's a correct way to get the grayscale version of an image, right? Let me guess, I'm going to have to loop through it. Oh yeah. Color matrix, I don't care about that. This is kind of the information that I want though, because these are the proportions that you weight it to turn it into grayscale. Because for each one I want to grayscale the pixel into an intensity value first. So what does this mean exactly? Does this mean we take 0.299 of the red component, 0.587 of the green component, and 0.114? Those add up, right? Yeah, okay, perfect. So they add up exactly to 1. So that must be what we're doing here. I don't know exactly how the matrix is laid out or whatever. So for the intensity, okay, low color, mid color, high color, and then call it the mid intensity. So that's like basically where it's going to be. So if I give it like 3 colors to work with, the low color is always going to start from like the 0, 0 pixels. The high color is always going to be the most intense, probably after the normalization, like the 0, 0, or the like 255, 255, 255 colors. And then I have a mid color, so it's going to blend gradually up to the mid color, and then from there up to the high color. This mid intensity is so that I can scale where in the range that mid is. So like if I want it to like mostly be blue, for example, I would set this mid intensity like kind of high, and then only the most intense pixels would pick up some of the like highlight color, which I think is more or less how I plan to do it. Well, we got the cat back again. Hi, kitty. So let's go ahead and pass through some values for that stuff. In the renderer, so let's give it a... I'll start there. And then we're gonna do... And this mid intensity is gonna be respected after the scaling, I think. Profile, the colors, okay. The low color, what's like a darker one here? The grit color, maybe? Give it like the base color. And then that color, like the strong color. I'm kidding, I'm busy coding right now. And you want to say hi to the stream? Say hi. Okay. Let's pass it those for now and I might adjust them or whatever later. So, in the profile, well, I always forget where I was doing this. And the line art generator. Okay, now this is going to be the kind of interesting algorithm. So we're going to try to do several things in one pass here. We're going to start by the original color equals okay, so get pixel X and Y. Now, this is the pixel color. And the pixel intensity, this is where we grayscale it. I'm actually going to call it that. Pix gray equals, we just had those three things out, so it's going to be like C dot dot R times, where are these constants? I'm going to make them constants in here. Grayscale R equals, so what it was? No, it floats. Okay. I believe those were the colors. Okay. So we're gonna do pix color times R times grayscale R. And I believe this is gonna coerce the expression into a float. Yeah, so we know because we get the float output here. Plus gray. Oh, let's find it out. There's no reason to write grayscale. And the reason we do this is just because the human eye awards different intensities to each of the three types of colors that it can detect. So when something has more or less green, we perceive that a lot more as making the color more intense or less intense than when it has like than the amount of red or the amount of blue in the pixel. And especially blue, I think, is the smallest, like this 0.114, because blue is kind of like the least respected color among the three in your I forget if it's the rods or the cones. I think it's the cones that detect color. But okay, so here we get the gray color. Now for now, I'm just gonna do this. to cast this back at the end. So for now, I'm just going to set the output of this grayscale calculation back on the output image, which should look pretty much the same. It looks pretty similar. So it maybe changed a little bit because we lost whatever little bits of like grayscale information they were, but it was already pretty close to black with the thing, so that just cleans it up a little bit. No problem. All right. So once we have the Pix Gray, then here we want to do the I want to call these differently. Pixel source color, pixel source intensity. So the first thing we can compute is the output intensity. And the output intensity is going to be, we want to normalize it to that range in the middle. I wish is there like a shorter word for intensity? All right. So the pixel output intensity is going to be, and we're going to wrap whatever we do and then whatever calculation we have in here. And the calculation in here is going to be, we're going to take the source intensity and subtract, we want to subtract off, oh, you know what? To scale this up properly, I actually need to do another pass and get the min and max intensity. I need to find the max intensity in the image. No, I don't. I'm passing that in as a parameter. Oh, okay. Forget about that. So we don't need to determine the max intensity. We're just going to have the caller tell us the maximum intensity that we care about. And that's part of why we have this min 255 to whatever, is because this calculation could very easily go above the maximum pixel strength or whatever. Do I want to do this as floats? I want to do it as floats. So I actually don't want this to be an int. I want it to be a float. And we're going to get this as a float. And this is going to be the so, but that would imply that I pass in the source and max intensities as floats. Oh, I need a shorter way to write intensity. So we're going to convert these down to floats. So for the pixels output intensity, we want to subtract pixel source intensity minus the the source min intensity. That's the amount that we want to subtract off. All right. And then we want to multiply that by the inverse, by the reciprocal of the max intensity. By 1 over this number. Okay, so what's the reasoning of what we're doing here? So we have an image that, like, you know, in this scale from all the way from pure black to pure white is the most intense. We want to, and let's say that the range that we say that we care about is actually from like 25% to 75%. So first we're going to subtract off the 25% at the bottom, like this. And now we have like 50% of the image. To get back up to the max intensity, we're going to take, oh, you know what? That should not be the reciprocal of the max. That should be the range. I messed it up. Because our range here, if we go from like 25% to 75%, our range is 50% of the intensity. And we want the reciprocal of 50%, which is 2. Because once we get this down to like 0 to 50%, we want to multiply by 2 to get up to 100%. Okay. I'm glad I worked through that because this is not right. So, min intensity max. So the let's call it the intensity multiplier. This is going to be 1 divided by the max minus the min. So in that example, yeah, so this becomes our 0.5, and then we do 1 over 0.5, we get 2. And then down here, we're going to multiply this number. So let's do an example. Like if this was a very bright pixel, that's like 60% intensity, and our min is still 25. So we're going to subtract. So we're going to take that 60% intensity pixel, we're going to subtract the min, so it gets to like 35% intensity, and we're going to multiply it by this reciprocal, which brings it up to like 70 intensity. So we went from 60 to 70 intensity. And we should be able to use that to make stuff darker as well. If it was closer to the bottom with those example numbers, if our input pixel was, say, like 30% intensity only, then we're going to subtract the 25, so now it's 5% intensity, and then multiply it by 2, it's 10% intensity. So in that second example, we went from 30% intense down to only 10% intense. And in the other example, we went from 60% intense to 70% intense. So we're just kind of like maximizing the dynamic range of the image. So I think that's correct. Now, obviously, I can't set that like that, but floor that. If this really got to like 1.0, then this would actually bust us. This would be an illegal value. Do I want to leave this going above? No, I think I want this to max out. So here, I'm just going to do a... Just going to give it another min, just to make sure that we don't bust. And try to set a 256 intensity pixel. So now what we should be looking at when we run this is our intensity scaled one. Whoa, that's too much. Way too much, but that's why we made it a parameter, so we can play with it down. Now, a couple of good things happened here. It did bring out this outline. We can see around the edges. Yeah, let's clean this up step by step. So we can see around the edges, we have a couple that are higher than 16. So first, we want to increase that parameter. Let's just look at a couple examples so we can visualize what I'm talking about. Over where we configure this thing. So let's start by setting the min intensity to 0. So what should happen if we set min intensity to 0 is that we see a lot more of this grainy noise in the background. See how we see like more of it? We were filtering out a little bit, this kind of starry background look. When we set it to 16, we filter out some. Now I'm going to turn it up to 32. And we should be filtering out more of it. No? Is that not doing what I expected? I might have messed something up somewhere. Let's try to set it to an even higher value. If this doesn't clean some stuff up, then I messed it up. Yeah, that's not filtering this out, so that's not correct. Let's step through and see what we did wrong. Might be like bad division or something. The line art generator. So here, what are we computing when we get here? Okay, source min intensity. So source min intensity here is 64 divided by 256F gives us 0.25. That's correct. Source max intensity is 192. Divided down gives us 0.75F. That's correct. And the source intensity mult gives us 2. That's correct. That's what we expected. So let's iterate over the pixels. Let's get 1. So this pixel, we got pure black, 0, 0, 0. So the pixel source intensity here should come out to be 0, because no matter what we multiply these components by, they're going to be 0. Okay, cool. When we get the out intensity, that's going to be 0, because 0 minus 0.25 is 0.25, and then we multiply that by 2, so we get minus 0.5, but then that gets cleaned up. We can't go below 0, so we capture it there. So this one produces an out pixel gray color of 0, which it should. And then we set the X and Y to that pixel. Okay, that's fine. I might need to set like an if in here to catch one of these that's not 0. Because there's going to be a lot of these that are 0. Okay, I'm going to do this. It's kind of a silly trick. Let's just pick one of them. So if we get one where the green component is greater than 0, just make any kind of statement in here. We can block on. Alright, let's do this again. So this time when we render, we should hit a breakpoint the first time we see a different source color. Okay, so here we've got one that's literally 111 source color. So let's do our calculation. Pixel source intensity is 1 times the gray R scale plus okay. What did we come up with here? 1. Okay. Is that correct? Yeah, because they're 1, 1, and 1. So we get 1 times the red component, 1 times the blue component, or green component, and 1 times the blue component. And we add them all together. And we get 1. Wait, am I just black and whiting the thing? This might not be right. Pixel source intensity. This is a number that's going to be 0 to 255, because that's how I was doing it originally. And this source min intensity is going to be 0 to 1. So that's what I'm doing here. I'm missing that after I multiply this, because yeah, the output of this should absolutely not be 1. The output should be like 0.00 whatever. So this whole thing needs to come down that's what's going wrong. Okay. Oh. I'm going to leave this in case we need it again later. Well, let's just check it again. Let's go through here and check to make sure that that case got fixed. Just run it, tell it to generate the profile. Okay, G is 1, just like before. So now here, for this pixel source intensity, yeah, 0.0039, whatever. So that's the actual like 0 to 1 intensity of the pixel. And then we calculate that, we're going to do that one minus the source intensity, which is 0.25. Okay. And that gets normalized out to 0, which is correct. Now let's try to do a higher one, like if we get a G higher than 128. Are there any G's higher than 128? I don't think there are any. Oh, but okay, so first of all, we can already see that now we're subtracting out the 64, which is too much. So, okay, let's switch back to what we were talking about. Well, one step at a time. First, let's get this down to like, let's find one where the G is higher than 32. There should be, no, there's no G higher than 32. It doesn't seem right. G greater than 16. Oh, do I just not have a breakpoint set? Is that what's going on? I just didn't have a breakpoint set. Okay, so this, so now let's do the calculation. This one has a G value of 42. It has R42, G42, B42. You know, I'm kind of suspecting that the printer actually already exactly grayscaled this image, because that's like too perfect. I was expecting it to be. I guess this is like a black and white scan. That's fine. So now we're unnecessarily converting it, but I'm going to leave this stuff because there's no guarantee. Like we could have had an image that's colored and it's just mostly black and white, and in that case we'd still want a grayscale. So I'm going to leave that in there. In any case, so now pixel source intensity is here like 0.16. And this is still, so this pixel right now, because of the source min intensity, which is all the way up at 0.25, this is still going to come out to 0 for an output intensity. So now that's too sensitive. Now I can go back and show off what I was trying to show off a minute ago in the renderer. So let's set this back to 0. So our source min intensity is 0. Now we're going to allow everything through. And there, actually it already looks quite good because we're setting the grayscale of the thing. So you don't really have any of that starriness. And we're also, this is what we're supposed to doing. We're also now scaling up based on the max intensity. But we can still do the example. If we set the min intensity, I'd make it at least like 16 or 32. I don't want to subtract out too much at the bottom because I'm just trying to get rid of any little noise. Let's leave it at 16 for now. Actually, we lost a little bit of this edge here. Let's try to knock it down to, oh, it's already 16. Just make it 8. okay, so we still have a bit of that edge. And it's okay if it kind of disappears and it's just like a line that you imagine. That's okay also. I think until I see a problem, I'm going to leave it at 0. And if later some kind of effect causes some noise to show up in the background, I might turn it back up. Okay, yeah, I leave it at 0. So now you actually get this edge of the photo here, which is nice. This edge of the face. So now we'll experiment with the other one. Right now I have this set to 192. If I crank the source max intensity all the way up to 255, then we're going to get the original image. Oh. We're going to get the original that's not turned up wider at all. And what's going to happen if... so there's going to be some like highest pixel in the source image. And if we set this... If we bring down this value of the max intensity from 255 down some notches until we hit this like most intense pixel, well, no, it's still going to make a difference. But basically, when we set this lower than an actual pixel that it finds, it's going to get clamped at 1, at an intensity of 1, like max intensity. So I can use this to bring out some of the lines, like to make it sharper. Which is part of the thing that I want to try to accomplish. Let's try to bring this down to like 128. And we want to find a middle ground where like we've created a nice intensity of the line, but where we have not destroyed all the detail. Because this is basically going to destroy the detail among the pixels that are too bright. That's not bad in terms of bringing up the intensity. Just to explore what we got, let's make it even more intense. So that's like, I would say, too much. Now we're starting to see like everything that is any kind of detail is just white. Let's step it up by half. Halfway back to 128, I mean. Here, that's still, that might be right in the ballpark that I'm looking for. That might be about what I want to start working with. Okay, let's try it like that. I can always come back and fiddle with it later too. So let's leave the 0 to 96. The mid intensity, I'm not going to mess with the number yet until we see what the colors are going to look like. And that's our next step, is to go and apply the colors based on the intensity. Banner render. Well, I always forget where this is. In the line art generator. Pick source color, pick source intensity. Picks out intensity. I said I was going to make a lookup table. Let's do that first. So I don't want to compute this. New color. I want it to be an array of 256 colors. Now we're going to go all the way from 0 to the mid intensity, and then we're going to have a second loop. From the mid intensity to I less than 256. Okay. So actually I want this picks out gray, because I'm going to use that as the lookup. And we'll just go ahead and lock that out here. Now I guess in here I can actually go ahead and bake in the alpha is just going to be I, unless I give it some kind of alpha scaling factor, which I might end up doing because that might end up being kind of messed up. We'll try it first. Pix out C equals so pix out gray here, we're going to use it as an index into the color lookup table, which can be, so pix out gray is a value between 0 and 255. We're building a table between 0 and 255. And for each of those indexes, we're going to construct a color, and we're going to do it by lerping, basically, which I guess we can use my lerp function that I already built. This is going to be color dot, I think there's a way to do it with the source color. I don't see color util. Bring it in. This is going to lerp from the low color to the mid color. Well, I should compute some of this. No, the mid scale is going to be mid intensity minus 0, so just mid intensity. So the total range 256 minus the mid intensity. Is that going to work right? So if mid intensity was 128, this is going to be 128 minus, no, 256 minus 128 is 128, divided by this is going to be 0.5. Okay. If our mid intensity was like 64, we're going to get 256 minus 64 is 192. No, I'm doing this wrong. I literally just want the, because what's the purpose of what we're doing here? We're going from the low color to the mid color. So on the way from the low color to the mid color, we want the lerp parameter, the x there, to go from 0 to 1 as we, 0 at the bottom to 1 as we approach the mid color. And it's going to approach the mid color faster than it approaches the entire range. So we really want 256 divided by the mid intensity, right? Like, because if we come in here, let's say if our mid intensity is like 100, and we come in here with a value of 20, we want that to produce an intensity of 0.2. So we just want to divide I by the mid intensity. But something about that's not right, because our I is going to change. No, it's not right. It is right. Because no matter what the mid intensity is, we're going to be I divided by the mid intensity. So we just want the reciprocal of that. Yeah, we just want the reciprocal of the mid intensity. That's what we're going to multiply it by. So that way, if mid intensity is 100, then an I of 0 is going to be scaled by 0, and I of 1 is going to be scaled by 1 times 100th. So this is 100th, and this is going to be 100th. So 1 times 100th. There's going to be 2 100ths, 3 100ths, 4 100ths as we go up. That's correct. If the mid intensity was 200, then it's going to be 1 200th, 2 200ths, all the way up to 199 200ths. That's correct. Okay, so we just want high times the low to mid scale. That's how we're going to select between the two. Okay, then how we're going to do... And then how do we set the alpha of a color? I know when you do from ARGB, you can pass it an alpha and then a source color. Does it tell us more about that? From ARGB, there's it's going to be I, color base color. Creates a color structure from the specified color, but with the new specified alpha. Although this allows 32 bits to be passed for the alpha, it's limited to 8 bits. I think this does what I want. I think this is going to replace the alpha of the color. So it's going to take exactly the 3 color components from the base color and just set the alpha, which is what I intend to do. I think that's correct. In fact, we're just going to put it out here. I might end up needing to scale this alpha somehow. So we're going to store that color into the lookup table. Now down here is where we're going to need the other one. This is where we need 256 minus the mid intensity. So if the mid intensity was 128, we need 256 minus 128. Low to high scale is going to be divided by there we want the opposite of it. And as we go there, so yeah, here we want this number as we go. Okay, so we're going to need I minus mid intensity. Let's get the same line. Still going to set the alpha. This time we're going from the mid color to the high color. This I needs to be I minus the mid intensity times okay, so this I as an index is still correct. This I as an alpha is still correct because it's going to go through here like 0 to 127 and then here like 128 to 255. So it's going to fill it all out. I'm going to take the I directly, mid color to high color. This is I minus the mid intensity, so that's the part, yeah, we want to reset for the scalar. Is but this is like 128, and the mid intensity is 128. And we want 128 minus 128 is 0 times the low, so low to high scale, this should be mid to high scale. What's wrong with this? That's the equals. Mid to high scale. And then as this one approaches like 255 or whatever, then we should get up to like 255 minus 128 is 127 times this scale, which is going to be like 128, the reciprocal of 128. So okay, that should be correct. That should be correct. And then down here, we're just going to do the lookup. Hopefully we don't get any index out of bounds garbage. It's the picks out color. And then this one is going to be the picks out color because we wanted to keep the alpha that we set. Okay, let's see what that looks like. Oh, okay. So there we colored it some. The alpha treatment seems like it's doing okay. And now we painted it over the background, which is cool. Yeah, the alpha treatment is alright. How come? I thought this was going to be... I think it's because the X profile colors is like, it uses pretty much the same color, exactly the same like color range for the profile and texture and stuff. Let's go ahead and make us a... so we can test it with some different colors. I might as well just create it outside the thing because it's going to make me add it. And the profiles. Gonna rename you YouTube profile. Add that in here. YouTube profile. Theme is YouTube. Type is profile. Do we have any information about what does YouTube want it to be? Oh, you know, this is what I looked up originally. 800 by 800 is YouTube. So it's the other one. It should be X optimal profile picture size. So X thinks it wants 400 by 400. So I should leave this one at 800 by 800, and for the X one, I should bring it down. Okay. So because we have the YouTube one, which is in red colors, I think I'm going to change that later. I don't really like it. For the YouTube profile. Ah, okay, there we go. So that's pretty blood red. I think I ended up doing the same thing with the YouTube one. I ended up doing the same thing with the YouTube one where I basically like made all the colors part of one theme because I was annoyed by how different they look. The Twitch one has a little bit more varied colors. Let's go ahead and create those also. Let's do one for each. So we got a Twitch banner. So we got an X banner, an X profile, a YouTube banner, a YouTube profile. Let's make a... Oh, I always get messed up with these buttons. A Twitch profile JSON. And let's make a... Patreon profile JSON. Let's add those in here. Our Patreon profile and our Twitch profile. Okay, so in the Patreon profile one, Patreon theme, Patreon profile. Let's just go ahead and look up the sizes. Patreon, I think, yeah, wants it huge, 1024 by 1024. And I'm using the AI answers for this because I could be wrong, but I can always go and fix it later. And then for Twitch, what does Twitch want? Twitch wants 256 by 256, okay. So see, this is why we're doing this whole thing as a generator, because everything wants different crap. Everything wants a different size, everything wants a different aspect ratio. So we're generalizing it. Okay, Patreon profile, okay. Then this one. Twitch profile, Twitch type profile. So now I'm going to get it in each color scheme. So here's the Patreon banner. And a Patreon profile, which does, yeah, see, this is the effect that I wanted it to have. Look at that. So because we're going from like the mid color to the high color, say you get this like it's not just more intense and less intense, you can see like the pencil detail that was there because it goes from like this orange color to this yellow color. It's mixed around here. The lower intensity parts pick up one color and the higher intensity parts pick up a different color. That's exactly the kind of texture that I was going for. So here we got a Twitch banner and a Twitch profile. And this one looks small because it's supposed to be small. It said 256 by 256. So as you get it down to this size, I guess that's what they expect. Oh, that's already getting the effect that I'm looking for. That's super cool. Video frame one doesn't have. We have the X banner and the X profile. Okay. YouTube banner. Takes forever. That really takes forever. And the YouTube profile. I'm probably going to come and adjust these colors. I actually don't like the red at all. I don't like the red for YouTube, and I don't like that orange for Patreon. I don't care what the platform colors are supposed to be. I think for Patreon, you can actually even pick a theme. So I'll come and vary those theme colors. But the cool thing is that they match. So like, my Twitch banner is like kind of purple and like pink, I guess, but not. There's a subtler word for pink that I'm thinking of that this shade is. I don't remember. Oh, this is the best one in terms of showing off. In fact, I'm probably going to use this as an example to set my other texture colors. This is the right kind of blend where you have some that are like the stronger color, and then you get a lot of the texture in the lesser color, and like the base color. So that looks really cool the way it is. All right. That's an excellent step. I'm going to go ahead and check that in, and then I'm going to think about if there's something else I can do to it. Alright, I'm going to take just a quick break, and then I'll come back and do one more thing on this. Okay, and I'm back. So, let's just take a look at this again. I love how that Twitch one's coming out. One of the things I wanted to do a bit more like kind of blurring. I might do like a pixelate on this, but I don't want to pixelate it too much. I could try the look of that. Let's try it really quick. The main thing that I want to add on top of this is like a laser eyes effect. And it's probably super hard to code like a proper lens flare, but I was just coming up with an idea for an algorithm, how we could get something that might look cool. I'm concerned it won't look cool, so it might not be the final one. And I don't want to stay on too much later tonight anyway. So first, let's just give it a little try with the pixelate thing. I'll just see how it looks. If it doesn't look good, then I'm gonna leave it alone. So here, we might want to do your pixelate filter. Let's do like 4 and 4. And I forget what the good modes for this are. Let's try to have it scale down low and scale up like hard. Let's try to pop that on it. See what it looks like. Let's do like the X profile. Oh, that's way too pixely. That destroys a lot of the detail, so I don't really like that. What if I give it like 2 by 2? Does that still look nasty? That's going to be too small to be seen on the higher resolution ones. The Twitch profile. That still looks nasty. I don't really like that. I like the detail of it. I'm going to turn that off. I could try to put my noise thing on top of it. Wow, this video frame one takes forever. I could try to put the noise to sparkle it up. You know what? I don't care about that stuff for now. This is an excellent starting point. It's an excellent base. Let's see what we can do about those laser eyes. I think for that, I was thinking about how to implement it. I think I want it to be a filter that you pass at the input and like the location in the image and something about the size, and it just draws it directly onto the image. And I'll see if we can do like an additive blend mode. Is that a thing? Anytime you want like cool laser or light effects, you always want like an additive blend mode. System drawing, you must implement a custom per pixel blending function using locked bits. System drawing or graphics does not natively support an explicit additive blend mode. Come on, are you kidding me? We don't have additive in here? It's like the easiest thing in the world. It's even easier than the default drawing mode where you just like have to blend it by the alpha. Well, that's fine. We'll just do it. So I was kind of thinking like it would have a series of lines, like that kind of go across, and then like as you get to a certain axis, the lines would randomly get longer, and as you get away from that axis, they would get smaller. So you get kind of like a sharp line or whatever. But I'm worried that that's not going to look real good. Since we're going to have to do per pixel stuff anyway, I wonder if there's literally just like a per pixel algorithm where I could make some kind of calculation about like the angle of the pixel to the thing and then randomly set that pixel's intensity. based on the average. That might look super weird. Or it might not look super weird. There might be a way to make that work. Alright, let's try it. Just for fun. That's going to be in our filters. Make a laser flare filter. Actually, probably won't even end up using a constructor. Gotta do that every time. Now, what am I thinking here? So basically, I'm going to iterate over pixels in a box, in an area. So I want to take a source location, and then I want to parameterize it by like a, basically like a maximum length, and then it can compute the size of the box that it wants to draw in. Oh, come on. Let's have you take doing it like this. So a center X, a center Y. I want it to have a what's that called? The length, the extent. And then, so if I just do it spherical, it's going to look okay. Maybe I would start with spherical because it's kind of a complicated algorithm I have in mind. And then we can like stretch it out, like make it respect certain angles. It's a separate step afterwards. So you can get a center X, a center Y, min extent, and max extent. And then we can give it, I guess from those two extents, it's going to calculate the size it wants. It's going to make a box that's like twice the max extent by twice the max extent to operate on. Alright, it's going to take a, we want to give it like a color to be based on. It's probably like near the lower extent it's going to be, well, if we're going to do additive, then yeah, we want to add a portion of this color. Okay. I'll make it one of the first things actually. Okay, laser color, center X, center Y, min extent, max extent, and later I might add some kind of like angles of interest, kind of, or like emphasis angles. Let's try to set one of those up in the renderer. New laser flare filter, which is, I'm actually going to have two, and I'm going to have to figure out the X and Y. Oh, that's kind of messy because I really need the, you know, I might set them as floats of the original image. And so then I can actually like configure them in here and kind of play around with them until they're in the right spot. And it's going to remain the right spot for all the different resolutions that we render. So let's go back over here. Let's make these floats instead. the min extent and the max extent are going to be taken from probably based on the height of the image. Or like the maximum of the height or width of the image. Alright, let's configure it like that. So this is going to be laser color. Let's do like the highlight color. I might end up creating a color just for that, because it should be very distinct from the other colors. Center X. That's not the right place for the eye, but I'm just gonna put it there to guess, and then we can like play around with it later. Like 1%. Like 2% of the image dimension to 15% of the image dimension. Okay, that's everything we need. Then I'm gonna do. Oh, we need this to apply to the out bitmap. So we render this down onto the out bitmap. We're gonna apply it to the out bitmap. Okay. Why not? Laser flares, okay. So well, let's just start playing with any algorithm and see how it goes. The laser flare filter. So first I'm going to have to compute some extent type stuff. Center X is going to be center X times the out bitmap width. So we get an integer height. Our min extent. Min X is going to be based on let's first calculate largest dimension is going to be so we get the grade, the larger of the width and the height, and then we're going to do a min X. This one I guess doesn't have to be in it necessarily, but we'll do it that way anyway, I guess. We're trying to get it in pixels. Well, whether it's an int or a float, we want it to be in pixels. Well, that's going to be the largest dimension times min extent parameter. Okay, I'll figure out what those need to be later. Now we're going to go from minus max extent to max extent. I guess what we want is the, because we don't want to bother with the parts that end up falling off of the image, so we're going to have to do some min X, max X type stuff. Let's see. Let's first just calculate it naively and let it go to negative numbers. X to x1 equals x0 and x1, or xa and xb. X to xa is going to be center x minus max x. Okay. All right, so then any of those that are should be YB. I guess we can actually just do it right here. So whatever's larger, 0 for this expression. Is this coming out to a float? I want these to be ints, so actually I do want to convert these back to ints here. Okay. Maybe I want, well, I'm thinking of a lot of different algorithms. So we're going to not let this go back past the start of the image on the side. Actually, I'm going to do it, should be -1. So the highest the extension xb can go is the last pixel. We're going to do I want to put parentheses on these also. And this is going to be whatever's smaller, height -1, or that number. Okay, so now those are nicely clamped to the dimensions of the image. And now we're going to iterate over those. Next, xa, which has to start at least 0. As x is less than or equal to x to xb, and that's safe for it to be equal to that because we made it width -1 as the limit. X plus plus. I did x on the outside. I like to do y on the outside so you can imagine it like going in rows painting across the screen. Oh my god. Okay, so we're iterating over the pixels in this box that we constructed from the extent. The last thing I want is a random generator here. I might pass in a seed later so we can lock it to a specific pattern. Okay, so for each pixel, the core of this algorithm is gonna it's gonna use the distance from the center, the distance from this pixel to the center, to determine the probability that it's bright, and then it's going to add a certain multiple of the color to the source pixel that's there. And so first, let's get that distance calculation. And this, I might make this distance calculation later sensitive to the angle that it is from the center, so that you could pick an axis like this or whatever, and have it be more likely along this axis that you get a pixel, or that you get a bright intensity, and like less likely along this axis. And that's how we get like an interesting shape to the effect. What's the Pythagorean theorem again? Like, we want the square root of a squared plus b squared. Center x minus x to the power of 2. Y to the power of 2. What's wrong with this? No overload takes. Oh, right. C squared equals a squared plus b squared. That's what we give it though. Alright. So for right now, I'm just gonna do. So if d is greater, if the distance is greater than the max extent, we don't want to do anything. We never want it to have pixel. So now we just confined it to a circle. And then within that circle, I guess just to make sure we're actually doing something, I'm going to have it compute intensity very simply. That should be, if we're at 0, we're like the super brightest. And if D is equal to max x, we're at the super darkest. So this actually needs to be inverted. Well, first of all, this is doing, does integer division become double division? How does that work? I'm always confused about this. C# integer division truncates towards 0. That means the fractional part. It's not quite my question. Dividing one integer by another integer results in integer division, which truncates the result towards 0 and discards any fractional part. That's what I don't want. But why does it think it's a double? Oh, because D is a double. The math.square root is a double. Okay, so as soon as I'm doing a double divided by an nth, then I'm just going to make it explicit. So now we're doing double division. So basically, if I had casted D to an int, which is actually kind of what I want to do, then we would have to cast, let's make these squares. Okay. So now that should go, this should go intensity 0 when it's at the center and intensity 1 when it's at the outside, which is the opposite of what we want. Now we want it to go. So now we want it to be 0 when it's at the outside to 1 when it's at the center. And then what do we want for now? C equals get the pixel at x and y, and we basically want to add to this pixel value because we want to do additive rendering. So we want to take the color that we just got in, or we want to take the color that we were passed in, the laser color, multiply it by this intensity, add it, and then clamp the result. And that clamping is what's going to make it turn like white as you get a bunch of it stacked on top. So source color. So we're going to make it, because at this point we're painting on the thing that already has background image or whatever. So it's fine that we're not generating a new one that has to have alpha and is going to get painted on something. We're operating on something that already has background, it's already max alpha. And then this is going to be, so the red is going to be math.max. I think I want to actually make multipliers up here. Like the each of the color components divided by 255. Or no, because the color components are already from 255. So this intensity is going to go, we maybe just multiply. There should be a source color red plus our laser color red times the intensity. What's wrong with this? Oh, I need them. Whatever's smaller, that or 255. What's wrong with this? Is it just because I don't have the other ones yet? Yeah, okay. Let's do the same thing with the source green plus the laser color green times the intensity. Source blue and the laser color blue times the intensity. Oh, come on. What's going on with it? Is this giving us floats? Or is it giving us doubles? So actually I want to, inside here, this part needs to get cast to do an end. Okay, and then we want to do set pixel X and Y to the out color. Okay, so right now this is going to look really bad, but it's a starting point. It's a jumping off point. We're just making sure that we're actually rendering something on the screen. Okay, so there we got kind of a... Now this is interesting. Why is it clip at the center? That's not right. Max 0, CX minus the max extent. CX minus X, CY minus Y. I'm going to see what I messed up in here. Alright, so we ended up here with center X is 64, center Y equals 64. Yeah, because this is a 256 by 256. The largest dimension of the image is 256. The minimum extent comes out to 5 pixels and the maximum extent comes out to 38 pixels. That seems reasonable so far. So then our extension A is going to be 64 minus 38, right? Extension B is going to be to 102. Y is 50. Okay, so we're not clipping the edge of the image, which is correct because we didn't see the, oh, well, let me click it. So that's wrong. if D is greater than the max extent. This is square root, so this is not going to be negative. This line should always be, like, what's the distance we compute here? 38. So we're at the max extent. We're not greater than the max extent. Intensity equals 38 divided by 38. That gives us 0. So that one's like the furthest away possible, so if it's 0, okay, that's fine. YA to YB, XA to XB, that's correct. The intensity is 0, so we're going to get like source red is 16, our laser red is 0, so that one's boring. 16, our laser red is our laser green is 128. Source blue is 16, 128, but they're all 0 anyway, so it's fine. X plus plus. D is 37. Okay, so this should be a little bit closer. I might need something divided by 2 here. So that gives us a small number, like 2% intensity. Okay, that all seems right. So how come when I let it draw, it's clipped in half here? It should not be clipped in half. It should be, if I move it, does that fix anything? Zero, C minus the, oh, that's what's going on. That's why it's going just a little bit below. It's doing the Y minus the min extent. So it's only drawing up like 5 pixels instead of drawing up like 38 pixels like it should be. There we go. So now I got a nice little circle there. Okay, now let's do the renderer. Now let's try to position this thing better. So the center Y needs to be like closer to 40. I'm literally just gonna guess and check this. I don't care. Let's try like 55, like 50. $55 is too low, so closer to 50. And this needs to move over a bit. 30. Now almost needs to come back like 2 and go up like 1. Needs to come back like 1 more. That's getting pretty close. Let's go back like 40. No, now it needs to come down when it's too high. So center Y. No, still. Since I moved it back. It still feels like it needs to come down more. That's gonna be way too much, right? I'm messing with the X. I'm getting the wrong one. That's what's going on. This would be 28. this one is the one I should be bumping down. That's too low. So go back to like closer to 50. Which is like dead center. Yeah, okay. Let's bring this to 49 and this to 27. No, it's too high. Alright, back to 50. 50 is the perfect sweet spot. Okay, that's good enough. So there we got one eye. Now let's get the other eye. Should I let these have different? Maybe I will let them have different parameters. Laser flare 1, or block for laser flare 2. Okay, laser flare 2. We're just gonna guess and check it. Let's put this over at like 65. Almost leave the Y there. No, it's too far. The Y needs to come up a little bit, and the X needs to come back. Let's try this at like 60, 48. No, still too far. 55. No, still like 48 on the X. Or 50 on the X. Twitch profile. Okay, that came out about right in the X. Then I just wanted to bump down a little bit. So 48, it's just gonna be 50. It's literally the dead center of the image. How funny is that? No, I made it too low. That should be I guess 49. Yeah, that's about right. Okay, so that already actually is a cooler start than I thought it was gonna be. I don't mind that. The additive, it's the additive does all the magic. Patreon profile takes more time. Oh my god, because of the colors. That's so much more intense. So it has this kind of big halo effect that I don't like. That's what I want to try to rein in. Like, I'm okay with it being this intense and like a spike to the side, but I don't want it to be that intense the whole way. I think what I really want is kind of like two angles, and if the angle between the two pixels is high enough, then it keeps the multiplier, and like where it's not high enough, it multiplies down. I think that's pretty much what I want. And if I have two angles, then it's like the rule is going to be, it's like how close it matches the first angle times how close it matches the second angle. That's not right, because that's going to cause it to get brought down everywhere, because it's never going to match both angles. So we want like let's do it with one angle first. Let's get how do I want to represent my angles in like radians? under. One is 45 degrees in radians. .7. Alright, let's just take that. Well, it's like math.pi over 4, right? 785. Yeah, exactly. Okay, so let's get like okay, let's put under a float. We'll do the same thing for the second one. Okay, 4 pi over 4. Now, how am I going to handle that in the flare filter? So we have the x and y. I might have to look up how to do this. I'm terrible at trigonometry. It's something like the dot product that we want. Basically like how do I even ask this? Because I want something that goes more or less to 0 when the angle is like perpendicular to this one. And I want it to be 1 when the angle is parallel to this one. Between two vectors? Between 2 points. Okay, on arctan, to get the angle between 2 points in radians, calculate difference in x and y coordinates, then use arctan 2, which returns the angle in radians from the positive x-axis. Okay, let's try that. So here I'm doing these, there. Distance x. What's this? Use distance y. Now 10(2) dy dx. So that's yx. Yeah, okay. For the angle between two vectors. Okay. So there we have an angle. Now we know the angle to the thing and from the thing. So then how do we make it so that we can subtract, first of all, the angle distance, the angular distance. Let's call this A. So the distance in angle is going to be A minus the large flare angle. And that's going to give some wonky results at first because it like wraps around or whatever. So, because if A is at 0, if the angle is at 0, like if the pixel's directly above the center, and we subtract 45 degrees, then we're going to get a negative. So we need to wrap that around to positive. No, we want the absolute value of the difference, I guess. Okay. And then so we get the absolute value of the difference. And then turn that into a 0 to 1. A really dumb way to do it would be to literally just divide it by max radians. intensity equals distance and angle times mass rad reciprocal. And this what I've been calling the pixel. The intensity is really the actually angle intensity. This is the distance intensity. And then I want my total intensity to be some calculation of those two things. For now, I'm just going to multiply them, even though it's probably not right. But if angle intensity is going to be 0 to 1, then distance intensity is going to be 0 to 1. Then at least it should give us a number between 0 and 1. What does that do? No, it's not good. It's clipping in the middle somewhere. I mean, I could make it more visible by like squaring it or whatever. I could add them first of all. That might make it more obvious what's going on, even though that's absolutely not what I want. Okay, that does show off whatever's happening here in the middle. So there's some kind of thing when it reaches. So we have the angle minus 4 to 9. Okay, for now. Let's just see the angle intensity portion of it. Okay. So this has got multiple things wrong with it. It's kind of, the Atan2 is not like linear and smooth. As we get to 0. I don't know if that's actually what I want. Incomplete. Similarity between two angles. Find the coordinate points. Find the points. Two angles you need to. Oh, that's like for a triangle. That's not what I'm talking about at all. So this Atan2 thing is not what I was expecting it to do. Let me just see a graph of Atan2. Yeah, okay. Minus, so it goes from minus half pi up to 1/2 pi. And down here it goes from minus pi. Wait, is that what's going on? Does Atan2 return negative such that tangent of x and y, or x, y is 1 now. X, y in quadrant 1, 0. Theta is less than half pi. In that quadrant, it's more than half pi. This is not like a nice, smoothly varying function. This might not be what I want. I might have to actually like figure out how to do it instead of just guessing and using the AI. But alright, let's start this. So, this max rad reciprocal really, first of all, is too large, so that's probably why I'm getting the chunks. Should be well, no, that's not right. So if we can go down to minus half pi, then probably the first thing I need to do is add a half pi to it and then multiply it by 2 to bring it into radian space. I'll leave that alone. tan 2 plus a half pi. And then take this whole thing, which now goes from 0 to pi, and multiply it by 2. What does that do for us? Well, we lost one of our discontinuities, but we still have the other one. It's still not responding to the angle that the thing is almost at all. Well, it's kind of doing what I want. Like, there's a region here where it has almost no intensity. And there's a region here, kind of at the edges, where it has a high intensity. So it's like partly doing what I want. It's doing it in like one quadrant. Maybe I just need to figure out the quadrant where it does what I expect, in special case each of the 4 places it could be. So I want to actually verify this. The angle and radians of a point xy from the center, you typically call functions. Wait a minute. No, that's right, still. Because, okay, determine the x and y, yeah. Call the function. As the y coordinate is the first argument, and the x is the second argument. So these might need to be flipped to fit in the coordinate plane correctly. That might be the first thing that's wrong, is that the minus dy. Without doing it, so what is that doing? Okay, so this, well, it's almost right. I need to flip the x also. But then that's going to be the angle of least intensity. But that's almost correct, because what it's doing in this angle is what it should be doing. Like, this quadrant is getting the effect that I want, where the intensity goes, except it's inverted. Like, the intensity is 0 there. So in the case that I have negative x and negative y, it's doing what I want. Alright, this is going to get really wonky. Angle dx equals to dy. So here we're trying to flip both of the coordinates to force them to be in that particular coordinate plane. You know, I think those lines I'm seeing are actually from the background. I can't tell if it's from this or not. So that's still doing what we want. And now this is kind of doing what we want. Except we, an angle of 45 degrees. Yeah, because look, this line continues outside. So I'm just highlighting that background line. So yeah, now it's more intense as we get closer to this angle and less intense as we get away from the angle. Now the next thing I wanted to do is basically I want it to go in both directions from one angle. So how am I going to accomplish that? Really, it's like, yeah, right now it's just the 45 is like upside down. If I undo that problem. Now it's putting it down here. So actually I need to flip both of them to get the most intensity. No, it's going down here. What the hell? Oh, first of all, I'm not even passing it. What the hell am I doing? I'm not even using the flipped ones. Okay. Well, that's doing something. Except at 0, it's all messed up. No, I think it was closer with dx and dy. I'm just not worried about this part right now. So there, the intensity is over there. But that means I should need to flip dx again, which is how I start. Oh, actually, you know what? I'm stupid. That is correct. Because it's at a 45-degree angle. So it is most intense along the 45-degree angle. Okay. So then, probably what I wanted to do... I know how I can accomplish this. So whatever value it's getting here, I want it to actually, like, go through the middle. This one, I actually want to multiply it like this. So di times rad reciprocal. Let's get the absolute value of this term minus 1. Right? Because if I get this term times 2 minus 1. So if the angle difference comes out to be 0, the distance and angle, if that turns out to be a 0 term, wait, angle, that's the angle. Oh yeah, here's where I'm multiplying it down. So if this turns out to be 0, times 2 is 0, minus 1 is negative 1. And if this term comes out to be 1, 1 times 2 is 2, minus 1 is 1. Well, let me do that again. If this term comes out 0, times 2 is 0, minus 1 is negative 1. Okay, so it's 1 when this is 0, because of the abs. So 1 when it's 0, 1 when it's 1. And it's when it gets to the middle, then it becomes, okay. I think that's correct. Can we scale it that way? Not quite. Well, we're trying to make it symmetrical. Let's just step through this once and see what it's doing. Okay, so starting from Okay, dx dy. Okay, so 38 in this plus math.pi over 2. I'm giving it a half turn, which maybe I shouldn't be doing. And then subtract. .93 minus the large flare angle is 0.75. Because we're over here. Okay, so that's turned all the way around. 2.93. Oh no, it's not all the way around. It should be. Like, what should be our radians? For a 0 over here, this should be, well, it's only like here-ish. This is the center x minus x. So the center x, so x is like over here. Oh, you know, I'm like flipping these around. I was only using them, okay, alright. That's probably the first thing I'm doing that's confusing things. Let's try it like that first. Okay, so here we've got the dark in the correct place and the light in the correct place. And we've got the intermediate on the sides. So now let's try to step through again. Okay, so now our y distance is minus, why are we starting at x is 61, center x is 69. Why are we starting there? Minus 8 and minus 38. I expected these to be symmetrical. Extent A equals 31. What? What's going on here? Oh, because I skipped all the ones where the extent. Okay. Fine. So the first pixel that made it past where the distance is greater than is not greater than the extent is the pixel that's 8 this way and minus 38. So it's going across the top row. It finally got to one that's only 8 off. Okay, so this is a pixel that's going like at a very slightly, if this is straight up, it's going at a very slightly deflected angle that way. So in radians, what we expect to get if we have radian 0 is over here. Three plus pi radians, 2 plus pi radians, 1 plus pi radians. So first of all, these are going in the other direction than I thought. So 3 radians, 2 radians. So if 2 radians is up here, that's really close to where our pixel is. So that's correct, actually. So first of all, these wind the opposite way than I thought they wind. So we actually start counting around counterclockwise. 0 to 1 to 2 to 3 to 4 to 5. Let me say like here 1 plus pi, which is about like 4-ish, and then 5-ish, and then 6-ish. Okay. So that's helpful to understand. So my distance, so now that this number makes sense. When we do this calculation, oh well no, now because I'm adding this term to it. It's because it said it can come out negative. Okay. So that's in the wrong spot again, but that's probably why I need to flip the y. Okay, so now it's in the right spot again. So okay, let's try this again. So this is our first pixel where, yeah, -8 by -38. Here angle is 1.77, which over here should be like kind of in this, well 1.77 is going to be, yeah, like kind of over in this range-ish, according to this diagram. 1 radian is here, and then the 0.77 must put it somewhere right up around here. Okay, so that's fine. So that's the distance in our point in radians. So how am I measuring distance and angle? Is that angle minus the large flare angle. So this large flare angle is, I guess, a deflection from down here. From, if 0 radians is here, then this is a quarter turn, 0.78. 0.78 is going to land somewhere in here, right at 45 degrees, but for the opposite reason than I thought. Okay. So far, so good. Oh, alright, so let's work out the mental examples, what we actually need to do. So, if our angle is over here, and this one, so we do subtract the distance of the angle minus this one, and that's going to bring us down like over onto this, towards this side of the circle, towards 0, in terms of the number of radians. And this is where what I want to happen is that, okay, so after I bring it down onto this side of the, towards this side of the circle, then what I have left is the number of radians. Is it symmetrical for the other side? On the other side, if you subtracted it, it would go back this way. Can't tell if it's doing exactly what it's supposed to be doing or not. Anyway, the distance and angle that it sees right now between 1.77 and 45 is like this, the 0.99 radians, which is right around here. But that's not right. That's not what I want it to be at all, because the oh, that's why I'm multiplying it by max radian reciprocal. see what that number comes out as. So for this first pixel, okay, so that comes out to like 0.15, which is reasonable. The next one is going to be x dx minus 7. So this should be slightly increasing. And it is slightly increasing. So I guess it's correct. I just don't understand why this, if it gets to 0 and it comes around down here, it must just be this part that I have messed up. This term times 2 minus 1, and then take the absolute value of it. Does it just put me right back where I started? Is that the problem? Did I get these backwards? Do I need to take this term like minus 0.5 and then times 2? That might be it. So cut it in half and then multiply it by 2. No, it still doesn't do it. I want it to be intense over here and intense over here and not intense there and not intense there. So am I messing it up somewhere else? I'm just literally making the alpha or the addition from that. Angle intensity equals so if I don't do that stuff, just take it back to the original. If I just made it this what does that do again? Oh, what did it do? Okay, so when we just did that one, now we have it inverted, where it's got the light color over here, the low intensity at 45, and the high intensity in the opposite angle. So how come we're not stretching this? Like, we're so close to having what we want. We got a 1 down here, and we got a 0 down here, and like something like a 0.5 between them. And all we want is to stretch that to a 1 over here, and a 1 over here, and a 0 in the middle. So it's just stretching, it's just multiplying. It should be... should literally be this. Yeah, we want to take this. Is it the math.abs that's messed up? No, because without the math.abs it becomes negative. This term goes 0 to 1. Let's see, what pixel are we at when we get to very high intensity? Oh, well here. How do we get that high? This angle is that. Next radian reciprocal equals that. Oh, because I'm still doing it times 2. Okay, take out the times 2. never hit one that's greater than 98. What about greater than 90? We never hit one that's greater than 90. Not greater than 50. Okay, we hit one that's greater than 50. Where do we hit it greater than 50? Dx is minus 38, dy is 1. So we go really high, like on the center line, maximally that way. So there, our intensity gets high because we're getting close to down in this area where it wants to be high. Now, is this always guaranteed to be? Let's check this. Is this going negative right now? No, it's not going negative. So I don't need to add this to it. It's already never going negative. Which means dA is always positive. Oh, it's always positive because I'm doing the absolute value, okay? Okay, so whatever comes out of this, take the absolute value of that and the distance, the angle difference. I seriously don't understand why this line isn't working. It should be exactly like this. This should go from 0 to 1 effectively. Max rad reciprocal 1 over pi times 2. Is it that instead of doing -1, I have to multiply it by 2 and wrap it? I don't think so. Let's do it one step at a time. That's definitely not right. messed up here. My brain is turning to mush apparently. Okay. So this goes 0 to 1. When we subtract it, then that should go minus 0.5 to positive 0.5. When we multiply it by 2, that should go minus 1 to 1. And then when we do abs, that should be right. I don't understand why there's still one intense side and one non-intense side. Maybe I treat it differently based on which one it's closest to. Oh, it's driving me crazy. It should absolutely work. I mean, because yeah, it doesn't come out the same. The location of the 0 should get changed. Zero to 1. Because I want to change the one that's currently 0 into a 1. So does that do that? So this is 0, 0 minus 0 0.5 is negative 0.5 times 2 is negative 1, abs is a 1. And I want to turn the location that's currently 0 0.5 into a 0. So if this is 0 0.5, and we subtract that, we get 0 0.5. Now, how come it was never getting to 1? That's probably where the answer is. It's never reaching 1. So this is definitely correct, but whatever I'm getting out up there is never equal to 1. So A minus large flare angle. So it's easy for it to be 0, and that's what we're seeing. That's 0, and this becomes 0. Oh, I might have to give up on this. I have to do it like this. Let's do it like 12. Okay. sine of that. Alright. Just X. Now I want what is A10? Turns the angle whose tangent is the specified number. Okay. Alright, so let's go through this. Test angle is 0, which means the x is 0, because we're right at the center, and the y is minus 100, so we're up at the top here. What is the A10 to? That does come back negative. That's minus 1.5. Does that square with this graph? The minus 1.5 is about right here. Yeah, okay, I guess so. Let's do the next one. Test angle is 0.26, whatever. The x is 25 and the y is minus 96. A10, okay, goes down. $49 minus 86 goes down. Good. 70 minus 70, so this is like the halfway point. And that comes out to the 45-degree number, except it's negative. It's like a 0 minus that amount. Okay. It's minus that amount. This is counting negatives. So as we go away this way, we're negative. Away from this line. Okay. To negative 0.2, negative 0.5, 0 when we have x is 100 and y is 0. Okay. And then we start counting positive. 0.5, 0.51, yeah, 7.8, 1.31, 1.57. So now we're positive all the way down here. Okay. So far, so good. Now what happens there? So here we're at x0, y is 100. So when we step back so that x becomes negative, that just keeps counting up. 0.9. 3.14, okay, because that's where y is 0 and x, so it's the point maximally over there. And then what happens? Ah, we flip negative. So it's minus pi to pi. Okay, so the angle, it starts at negative pi, comes all the way around here to 0, and then goes back around to positive pi, and then flips to negative pi. So how can I use that knowledge to get the right behavior here? How can I use that to get the right behavior here? Is that in the right direction? Yeah, it is. So it's most intense over there, least intense over there. And how do I arrive at that? Well, when I come in here, so now this one where I'm like -8 and -38 up in that corner, yeah, it's going to be a negative number. And as we go here, the number is going to get less as it goes towards 0. That's this number. Okay, so the first thing that we want to do, now for my purpose, I only care about how far away it is. So first, yeah, dA, we're going to subtract the large flare angle. In this case, large flare angle is measured in radians, because yeah, corner is going to be, so 45 degrees, minus there. So really, to get the angle that I'm imagining, starting at 0, that large flare angle would have to be like -1/4 pi plus the angle amount plus the number of radians. So as it goes around this way, no, we're multiplying by the radian, max radian reciprocal. So does that make any sense? So A minus the abs of A minus the large flare angle. From this angle, A could go anywhere from -pi to pi. So -pi minus the large flare angle is going to be too big. That's the problem. And the abs is going to be too big. So that's why first I was adding the ½ pi term to it. If I add the ½ pi term to it, then now 0 radians is over here. So 0 is over here. If I add a ½ pi to it, 0 becomes a positive. Oh, if I add a whole pi to it. If I add a whole pi to it, then 0 becomes pi over here. And what was pi over here becomes 2 pi over here. If I add a ½ pi to it, then well, 0 here. I think really I want to minus. I want to subtract ½ pi. So whatever is 0. I don't know if that's right. But this is multiplying it by the, well, no, this line has the problem first. Because right now, I'm subtracting the angle from this. And this is based on the idea that when these two get close, it's going to become 0. And then we're going to start counting up in the other direction. Oh, this is already over here. Then that's gonna bring it around. So I have to wrap that first. If this is plus the minus. It's less than negative pi. So here, if it went down here, then that would put it down here. Not supposed to be up there, buddy. Still do it. Okay, so if we don't do the abs, then we go from 0 down here all the way to 0.5 here, up to 1 over here. Okay. Well, I can get sonar eyes. So imagine I have this number, the distance from the angle. So first of all, having it laid out like that makes it really easy to tell if I need to flip stuff. If I flip the dx, now it's going in that. And if I flip the dy again, now it's going like that. But now that I understand how I'm configuring the things, 0.75 actually, or a quarter, actually is down here. 1/4 pi is this line. So I do want to flip the y also. Because really, this should be the 1/4 pi should be counting from here. Can't hang out up there, man. Oh, wait. So I've been getting it to stretch. What I really need is to minus multiply by 4. No. That's just the intensity. The largest dA you can have is a half pi. Right now, this is going from okay, so now I got half the circle where it's fully intense. Times 4. I multiply by 2. Well, it's got a part here where it goes to 0. I think this is correct. And that goes all the way around. Now what I want it to do is start 1 here. So it starts 1 here. So above this, A minus the large flare angle becomes a positive number, which means it's going up here, a small positive number. And below here, A minus the large flare angle, the angle of the pixel minus the large flare angle, becomes a negative number, which wraps it around here. So what I really want is basically to have it be based on the sign of that number. Holy shit, it worked. That's what it's supposed to do. Finally. Now it expands too much, so I need it to be like a... Yeah, that narrows it. Now let's narrow it more. Well, just a little bit more. Alright, let's try it like that. And then now let's try to factor in the distance as well. screen is so white. Yeah, that's the right effect. Well, I'll make it even narrower. And then multiply it by a constant. Alright, you know, that's as close as we're gonna get for now. Okay, so now let's shift that down some. Let's go in a direction. Well, it's not right yet, but I gotta stop there. Let's check this in. Stop.